was probably told that once. And just forgot.
Gotcha.
Wow. What?
Assume that I could
It's going, man. Had to get rid of the basketball practice.
But, okay, I had a little rough.
Mr. Davis, you're all that has a piece of lead in it.
So go. Yeah.
Did you take a piece of metal and try to reach in there and get it out for me?
So,
I don't really want to.
I'm kidding. Don't do that.
There's still one more day.
Right?
pick up the pace, Tyler. You gotta get
Don't
all
let
the guys.
Oh, I have no
So you tell me
idea.
just don't push it in?
Oh. I turned mine in today.
Are we still looking at the parking spaces?
You don't know.
Davis, what are we looking at now?
Of course,
Yeah.
Only ring.
Well, there's how I see it.
Yeah, we just tried trying to call her at that time.
Get your notes out, please.
So, second that for a slide.
Oh, I did too.
Whole thing right.
I have to give myself
within the last 11, I feel like
They already took your mic up for closing it up.
I really don't want to go.
like, hey, listen.
And then,
Good grass. They take up a decent amount of. Well, yeah, I'll do it. Sorry to interrupt your conversation. Yeah, right. Don't worry about it. Now look. Class didn't even start yet. Ignore me. Oh, okay.
It's absolutely
Did anyone else get an email saying something about overdue fines?
Yes.
Just make it clear. Overdue fines that are in January of 2021.
That just means that you don't pay immediately.
I think so too. You're like 8 feet away. Does it help if I move this? It probably doesn't.
It would help me.
Oh, yeah, no, that's good. Wait. I
Still no?
Yeah, I still feel sorry. I just
it
need
helps
glasses.
me, so thanks.
It's just
It helps me.
Jarvis lips keeps getting better and better.
Not one day.
So I was like, stupid.
I didn't even go in myself.
Show up 40 minutes late.
Those are pretty sweet shades, aren't they?
Yeah.
Yeah.
Which was a 59. For 1 hour.
Oh, because you're eating your iron. I thought it was about
Oh, yeah.
I was like, no, right.
Okay. So, absolute, and I'm going to do our couple graphs in a second, and we'll talk through a few of these situations. Absolute max and min are, like, you look at the entire range that you're given, and you give me the highest Y value if I ask for the max, or the lowest Y value if I ask for the min. Local max and min is just like the top of a hill or the bottom of a hill, but it might not necessarily be the biggest or smallest on the whole graph, just in its little range. So if I give you a graph, something like this. So this would be your absolute max, and this would be your absolute min, because that's like the highest point on the entire graph, and that's the lowest point on the entire graph. It's also a local max. It's also a local min, because it's in its little range there, it's still the biggest or smallest. And then this would be like a local min. And this would be a local max. They use relative and local like a lot, both interchangeably. They don't really use global. So they mostly stick with absolute for that one. For the local, they use local or relative. Yeah.
How can we tell what the quote-unquote neighborhood is?
It's got to be the bottom of the hill or the top of the hill, basically. I mean, so any other point on here, like if I say that point, just look to the left and the right of it. Is it bigger than both of those? Or smaller than both of those?
Yeah. I mean, it's bigger than one of them, smaller than the other.
Right, but it's got to be both.
Okay.
So if there's a point on each side that's smaller than it, it's a local max. If there's a point on each side that's bigger than it, it's a local min. So the neighborhood is just like really small, really. It's just so what I'm getting at is, what's the slope at a relative max or a local min? It's 0. So it's got to be the top of a hill or the bottom of a hill. So it's got to be like a turnaround. So that's, I'm getting that in a second. So, local, relative, extrema. Extreme is a cool word that means max or min. Occur when slope equals 0. And that's kind of what we're about to get into. So it's a turnaround. Does that help you with the neighborhood thing?
I just figured neighborhood would be the whole crap.
Well, that's like the city.
Okay.
That is like a little neighborhood. Like this is like my little cul-de-sac. Like I have the worst house in the cul-de-sac. I have the best
That's
house.
the next neighborhood over.
Yeah, that's the next neighborhood over. Yeah.
So that's Milan. The whole thing is Milan, and then there's just two little neighborhoods.
Sure.
Those are just two neighborhoods inside my neighborhood.
Yeah. So let's draw a couple graphs, and there's a couple things we got to talk about with those. talk through the absolute max, absolute min, and then any local max and local mins. And there can be tons of local max and local mins. There's just only one on this graph. But if I gave you something like a sine and cosine graph, like local max, local min, local max, local min, local max, local min, there could be an infinite number. And then the sine cosine would all be local maxes too, actually, because they're all tied. Did you get some donors? Did you get some blood? So wait, it's not Monday, it's the next Monday.
It's yes.
Right,
Monday
right
we
at
get back.
Thanksgiving. Okay.
Yeah.
Alright, so I'm gonna skip down to the local max. So the local max would be 2, so the max is the y value, and it occurs at the x value. So these are all gonna be y values, and these are all gonna be x values. The local max is 2, and it occurs at 1. Or you can say y equals 2, and x. Sometimes they'll say, what is the local max? Sometimes they'll say, where is the local max? Sometimes they'll say, give me the coordinates of the local max. So they can ask for the x or the y or both together. Where is there a local min? Like, what are the coordinates of the local min? 2, 1, right?
Right.
So that'd be like the turnaround, that'd be the smallest in that little neighborhood there. So the local min is y equals 1. That occurs at x equals 2. The absolute on this one is a little goofy. So if I said to you, what is the absolute max on this graph? What is the highest y value? It doesn't exist. Because infinity is not a number. Infinity is like a concept, so it's not really a number. We can say, oh, the highest point is infinity. Because then I can say, okay, well, infinity plus 1 is higher. And you can say, okay, jackass, infinity plus 2 is higher. I can be like, exactly, jerk. Infinity plus 3 is higher. You're like, okay, dickhead. Like, we can just keep going back and forth for hours and hours. And so the absolute max is not available. It occurs at never. What about the absolute min? What's the lowest y value on this graph? It's not 0 though, because that's an open circle.
So do you just not know?
So it approaches 0, so you could say, well, the lowest is 0.0001. I could be like, alright, we're gonna do this again. 0.000001. And you're like, okay, fine, if you want to play that game, 0.0000. So the local min in this case doesn't, I'm sorry, the absolute min in this case doesn't exist either. What's that? So there's a law that says no matter how close two numbers are, there's a number in between. So no matter how close you want to get to 0, I can put a number in between 0 and your number. So it doesn't exist.
I mean, it's like the same thing.
So you have to
Yeah.
have like a
I know what you're saying. We're saying the same thing. It's like semantics, right? Okay.
It has to have you have to have like a number.
You have to have a number where you can say that right there is the highest it gets. Okay. List any absolute max or min that you see, and list any relative max or min that you see. You can just do it in points, like you don't have to do the occurs at is stuff, so just absolute max, absolute min, local max. So just list them as coordinates. So where's the absolute max? -2, 2. Where's the absolute min? Doesn't exist. Because no matter what you say the smallest number on this graph is, I can give you a smaller one. Then you can give me a smaller one. Like that just goes forever, so you can't say that right there is the smallest. Local max, there are 2 of them. 0, 1, and 2, 1. Local mins, there's 2 of them. -1, 0, and 1, 0. And again, so getting to the point I'm eventually going for, what is the slope at every local max and local min? 0. So what type of tangent line exists at every local max and local min? Horizontal. So at each of these points, isn't there a horizontal tangent line? Slope equals 0. Or HTL. Slope equals 0. HTL. Same thing there. Same thing there. So local maxes and local mins occur at local max and min. Did I already read this? Occur at slope equals 0 slash horizontal tangent lines slash, how do I find either one of those 2 things? If I said, tell me when the slope is 0, here's an equation, what do you do? Well, the derivative equals 0. So what we're eventually getting into, and we're just kind of slowly building towards it, is I'm going to give you an equation. Say y equals x to the third plus 2x squared minus 6x whatever. And you are going to create, well, this one's not. It's got an endpoint, so it's weird. But you're going to create the graph. So you're going to have to be able to look at an equation and tell me where it's increasing, where it's decreasing, where the local maxes are, where the local mins are. And then the next level of that is the points of inflection. You guys know what an inflection point is? Maybe, yes, no. I mean, we'll get into it more later, but inflection point would be like right here would be an inflection point. Because prior to that, is the graph curving upwards or curving downwards? It's curving up, because you got this like U shape here. But then after that, it flips to more of like an N shape. You see that? It's the maximum slope of that little spot right there, yes. And then there's another inflection point kind of over here, where the slope, so now we're going from an N shape back to a U shape. You see what I'm pointing out?
So it's just in between.
It doesn't have to be like perfectly in between, but it usually is in between them, yeah.
Okay.
Not necessarily symmetric in between,
Okay.
but like, it's what Josh said, it'd be the steepest slope right here. Because it's curving up and your slope is getting bigger and bigger and bigger, and then at a certain point your slope flips back to getting smaller and smaller. And that's what you guys are going to have to find. Here's an equation. Find where it's, first of all, go back to like chapter 1. Are there any horizontal tangent lines? Are there any horizontal asymptotes or vertical asymptotes? And then, tell me where it's increasing, decreasing, relative max, relative min. And then, tell me where these points of inflection are, where the graph is curving upwards and where the graph is curving down. So when you take the quiz on this chapter, it's going to be 3 questions. And I'm going to say, if you have time to do all 3, I'll grade your best 2. If you don't have time to do all 3, just do 2 of them, I'm going to grade 2 of them. But it's a 3-question quiz, it's literally 3 equations. And I give you a full sheet of paper to do all of that stuff. So that's where we're like, starting to head down that road. It's not that hard. Like most people think it's okay. I'm not trying to like scare you or intimidate you, I'm just trying to tell you where we're going.
And you're working. It's working.
It sounds scary.
Yeah.
It's not that bad. It's really not. So the first step is find critical points.
What happened?
Whoa.
I feel like I took my glasses off. I'm like, wow.
I didn't know what you're talking about at first.
There we go.
So to find critical points, you just set the derivative equal to 0. So this is starting at like the very base level, right? So this shouldn't be too bad at this point. So as an example, if I say y equals, I'll give it like a super easy one, like x squared plus 2x plus 4. Go ahead and set the derivative equal to 0 and solve. If you pass the gateway, I think you should be able to handle this. Pass the gateway and you remember it, you should be. Okay, so you go y prime equals 2x plus 2. I'm setting the derivative equals 0, but I want you to think through why. Why are we doing that? What does that tell us?
Okay.
Well, it tells us where the slope is 0. And what happens when the slope is 0? There's a turnaround, or sometimes it's not a turnaround, but it's one of these guys. Like it starts to turn around, fakes you out, and it goes up. But that is a point of inflection. So something happens to the graph when the slope is 0. If I solve this, I get x equals -1. That's a parabola, right? This is the graph. So what's the x value of that term? X equals -1,
Yeah.
right? So that's what we're finding. And what's the slope at that spot when x equals -1? It's 0. So that's all we're finding. So it's just set the derivative equal to 0 and solve. I do want to review discontinuities also. Let me hand out your assignment. It'll be easier to go through a couple of those. I got it. You'll see.
Actually, I would be very grateful. Which one
Respect.
has is it this way or as
Yes, that was just a one.
Oh, that's right.
I didn't want to confuse
And
you.
it's urban. And it was $7. $7 for this big of a container. I was like, what is that for?
Okay. So critical points. Set derivative equal to 0. Discontinuities are when the bottom, and you can just use the original, equals 0. So I'm asking you here to find the x coordinates of the critical points and the discontinuities, because those are important points on a graph. It's where something happens. We'll review horizontal and vertical asymptotes before I ask you to do all that stuff again too. So discontinuities on number 1, where is there discontinuity? Where's the bottom equals 0? X equals 3. Remember what type of discontinuity that is?
That's a removable.
It's a non-removable, it's a vertical asymptote. So when the bottom is 0, and this, you gotta start remembering this stuff too. So when the bottom is 0, but the top isn't, like would 3 make the top 0 also? It wouldn't. So that's a vertical asymptote. So when you have to think about graphing these, that's one of the first things you'll do is put that vertical asymptote on your graph. And it gives you like, kind of sections it off for you. Let's review horizontal asymptotes while we're here. What do you look for horizontal asymptotes? Did you say coefficients? So why am I looking at the coefficients? Yeah, so I'm looking at the highest power. I think that's what you're trying to say. I look for the highest power. Is the highest power in this case on the top or the bottom? They're equal. So then you look at the coefficients. So where's the horizontal asymptote on this? Don't say 1. That's even worse. That's also bad. Y equals 1. Thank you. Horizontal lines are Y equals, right? So this would have, and I'm not asking you to do this on this worksheet, but I'm just, clearly we need to review it, right? This would have a horizontal asymptote at Y equals 1. It would have a vertical asymptote, let's just write it down over here. There'd be a horizontal asymptote at Y equals 1. There'd be a vertical asymptote at X equals 3. And so if and when I ask you to graph this, now you've got like, you've got 2 dotted lines on your graph, and it's already kind of sectioned off for you. What if the highest power is on the bottom? Where's the horizontal asymptote? Y equals 0. Thank you for saying Y equals, and also thank you for not saying X. If it's on the bottom, it'd be Y equals 0. And if the highest power is on top, or there is no fraction, then you don't have to worry about it at all. There just wouldn't be any asymptotes. There's only asymptotes if there's a fraction. So, if the highest power is on top, or there is no fraction, you don't have to worry about it. But what I've not done yet is any calculus or taken any derivatives. So, I'm going to take the derivative of this, and my job is to set the derivative equal to 0, because I still, after all of that, I still have to find critical points. So I'm going to think about that negative sign. I don't like it out front like that. I'm going to think about the negative signs being up there with the X. And then you could bring the bottom up and do product, or you could just do, or you could do quotient. I'm going to do quotient. So my derivative is the bottom times the derivative of the top, which is negative 1. Minus the top times the derivative of the bottom, which is just 1, over x minus over the bottom squared. And then if I simplify that, I'm going to get negative x plus 3 plus x over x minus 3 squared, which is really just 3 over x minus 3 squared. You with me on the derivative part? And my job is to set that equal to 0. Well, if you think about setting something equal to 0, the bottom doesn't matter. You can think about that 2 ways. For something to be 0, 0 divided by something is 0, right? Like I have $0, I'm going to split it among all of my friends. We all get $0. It doesn't matter how many friends I have. We're all going to get $0. You can also think about it algebraically. If I wanted to solve this, let's say I multiplied both sides of this equation by x minus 3 squared. What happens on the left is they cancel, right? What happens on the right? You still have 0, so I end up with 3 equals 0. So there are critical points on this graph. There are horizontal tangent lines on this graph. The slope is 0 on this graph whenever 3 equals 0. Well, when's that?
Never.
None. So there are no critical points in this situation. I've rambled a lot. I'm teaching more than the worksheet is asking. I'm trying to like give you a big picture view. All the worksheet asks for here. Tell me the discontinuity. Tell me if there's critical points or not. You should be kind of in the back of your head, like, do I know if this has asymptotes or not? But I'm not asking for that on this worksheet. So if I would do the second one with you, there's not a fraction here. So are there any horizontal asymptotes? Not. Are there any vertical asymptotes? Not. Are there any discontinuities? There's not. So I don't have to worry about any of that stuff unless there's a fraction. So all I'm looking for is no discontinuities. And all I have to worry about is critical points. Well, how do I find critical points? Set the derivative equal to 0. So I get negative 2/3. 5x minus 20 to the to the negative 1/3. Times 5, don't forget chain rule exists. It's amazing how many people, like, after the gateway, you remember product and quotient, but forget chain for some reason. I don't know why. It's just easy to forget that last step where you multiply by 5. And then this is, like, the reason that we've been putting things into one fraction, so we can set the derivative equal to 0. So this would become, okay, 5x minus 20 goes to the bottom and goes to the 1/3. And I get a negative 10 on top, and a 3 on the bottom. Crap. Yeah. No, I messed up. Critical point, set top and bottom of derivative equal to 0. Which is why we wanted to get things into one fraction, so we had a top and a bottom, which I've been talking about for like 2 months, and I forgot all about it. Set top and bottom of the derivative equals 0.
Wait, does that do the one above?
The one above, if we set the bottom equal to 0, what would we get?
We would get x equals 3.
Which we already had, right? That's why it didn't occur to me in the last one. So we were all set. So yes, technically we should have set this bottom equal to 0 also.
So wait, in that case, when we have a critical point, at x equals 3.
No. Because you can't have a critical point where there's a discontinuity. Discontinuity overruled. There can't be a point at a discontinuity. Can you have a point on a vertical asymptote? No. So the discontinuity crushes. I'm gonna try to be. Look, I'm a critical point. No, you're not. I'm a discontinuity. I could. Okay. But here it matters. So I'm gonna set the top equal to 0. When does negative 10 equal 0? Never. I'm gonna set the bottom equal to 0, and this little algebra trick is helpful here. The 3, the coefficient on the front and the power are completely irrelevant. If you're equal to 0, they don't matter. Because if I divide by 3, okay, I'm going to divide by 3, this cancels. So it's 0 divided by 3. I'm still at 0. How do I get rid of a power? I'm really good at this.
Would you cube 1 plus 0?
That already is cube root. I raised to the reciprocal. I raised to the third. Okay, so if I raise... Okay. If I raise this to the third power, this cancels, right?
Yeah.
What's 0 to the third? It's still 0. So then you just have to solve this, and you get x equals 4. So this is a critical. Should we do number 3 also? So let's talk through the asymptotes too while we're... Forget the worksheet for a second, because I know it's not asking for this. But are there vertical asymptotes in number 3?
Yes.
Yes, where? X equals 2. Are there horizontal asymptotes?
Y equals 1.
Now y equals 1. Y equals 3. Because you look at the coefficients.
Oh, I thought you looked at the power.
You look at the power to see where it's bigger. But then you look at the coefficients once they're tied. So if I asked you to write it down, which I'm not, but it's not going to hurt. Vertical asymptote x equals 2. Horizontal asymptote at y equals 3. Are there any discontinuities?
Yeah.
Where?
There'd be a discontinuity at x equals 2.
A vertical asymptote is a discontinuity. It's a type of discontinuity. But so technically there's a vertical asymptote at x equals 2 and there's a discontinuity at x equals 2. And then I gotta find critical points. How do I find critical points? Set the top and bottom of the derivative equals 0. Top and bottom, top and bottom. So if I go through quotient rule, the bottom times the derivative of the top minus the top. The derivative of the bottom is just 1 over the bottom squared. So this is like 3x minus 6 minus 3x over x minus 2 squared. So negative 6 over x minus 2 squared. So, set the top equal to 0. When does that happen? Never. Set the bottom equal to 0. The squared is irrelevant because if we square root of both sides, once the square is 0, 0 still stands strong even if you square root it. And I get x equals 2. Is x equals 2 a critical point? Why is it not? Because there's a discontinuity. So it's already x equals 2 already has a job. It's a discontinuity. And if I can't put a point on a discontinuity or else it wouldn't necessarily be a discontinuity. So we're just done. So the only answer that you would be given in this one is the discontinuity of x equals 2. Are we okay? You ready to do another one?
No.
You want me to shut up is what you're saying?
Yes. No offense. Like, no offense at all. Like,
No, it's okay.
just trying to.
You just want to know yourself.
Yeah.
I get it. That's cool. I'm gonna write some more in giant letters because I screwed up the teaching. Critical points.